Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
As usual, before we start our lesson today, let's pray. Pray begin. Amin. Right, welcome back, guys, to the lesson. Today we are going to proceed to another colligative properties. Maybe this is the last meeting for the colligative properties because next week we have to move another topic. All right. Last lesson we talked about boiling point and freezing point, boiling point elevation and freezing point depression. We say that the boiling point and freezing point depends on the molality of the solution, and we learn how to calculate the boiling point elevation and freezing point depression in the solution. We derive formula how to calculate the delta TB, and then after that we find the TB. All right, that's what we learned last week. Not last week, yeah, last lesson. Today we are going to continue with the last colligative properties, which is osmotic pressure. It is still also talking about the colligative properties. All right, before we start, let's check how many students already here. 18, 17. How many students outing? Only Alfie, yeah? In this class.
Oh, Mister.
Hello, Alfie.
Yes, Mister.
You don't join the camp?
Ini kalau jadwal komputer ini paginya ini aja, Mister, tutoring. Tutoringnya itu juga pakai record, jadi bisa ditonton nanti gitu, Mister. Okay. Sama juga ngebahas yang kontes malam. Yes, itu kata-kata. Jadi biasanya nonton setelah ini aja, setelah kontes hari ini aja gitu.
Okay. So 3 students are not here. Hambali still 6? I didn't see Hambali. Who else were not here? Only 3 students yeah, not here. Hambali not here. Siapa lagi? All right, we're going to check in the middle, yeah. Maybe they are now struggling joining the Zoom. All right, we're going to start again. I'm going to show you one video about the osmotic pressure. Okay, let me share my screen. So please watch the video and try to get the point from the video.
Osmosis is the diffusion of water molecules down their concentration gradient across a semi-permeable membrane. This membrane is semi-permeable because water molecules can pass through it. But solute molecules cannot because they are too large. The beaker on the screen shows a semi-permeable membrane separating a solution with a low solute concentration on the left from a solution with a higher solute concentration on the right. There is an overall passive movement of water molecules from the solution with a low solute concentration to the solution with a high solute concentration. This is because the water molecules move to even out any difference in concentration, just like in ordinary diffusion. This net movement of water molecules will cause the water level to rise on the right and fall on the left. Hydrostatic pressure is the pressure exerted by a fluid due to the force of gravity acting upon it. As the column of water on the right gets higher, the hydrostatic pressure it exerts increases. The hydrostatic pressure acts to push the water molecules back across the membrane, opposing the movement of water by osmosis. At some point, this pressure is high enough to stop the net movement of water through the membrane by osmosis. This pressure is known as the osmotic pressure. The osmotic pressure is determined by the concentration of non-diffusible solutes in the solutions. If there is a small difference in solute concentration between the two solutions, there is a low osmotic pressure. In this case, a small amount of water crosses the membrane by osmosis, raising the level of the solution on the right slightly. As a result, the hydrostatic pressure increases slightly, which is enough to prevent any further net movement of water. However, if there is a large concentration difference between the two solutions, there is a much higher osmotic pressure. A large amount of water can cross the membrane, raising the level of the solution on the right considerably, before the hydrostatic pressure will be enough to prevent further net movement of water.
All right, that's the video about it. Osmosis and osmotic pressure. All right. Andika, what do you understand from the video? What point you got?
Firstly, I get the definition of osmosis. Sir. So osmosis is the when the molecules throwing through the semi-permeable membrane, sir, from the low concentration to the high concentration.
All right.
And then about osmotic pressure, firstly, they explain about hydrostatic pressure. It's because of when the low concentration, when the low solute throwing to the high solute, so the low solute will be decreased and the high will be increased. And the hydrostatic pressure is force of gravity, so it will be decreased again and can make osmotic pressure, sir.
All right. It's not totally enough definition, but mostly it's true. Thank you, Andika. So in the video, we are talking about the osmosis and osmotic pressure. There are two different things. The name also different. Yeah. Seem to be the same, but it is different. The first one is osmosis. Osmosis process. This is a process. And the second one in osmotic, with C, osmotic pressure. Okay, so it is two different things. If we want to define the osmosis, this is my definition, not the definition from the video, but it's the same, yeah, the same concept. I define the osmosis as the movement or in the video it say that it's diffusion, yeah. Diffusion is actually a movement, yeah. Okay, a movement or diffusion of solvent, yeah. In the video, because the solvent is water, let me write this water, molecules, okay, from low concentration solution to high concentration solution. through, this is important, through semi-permeable membrane. So there must be a semi-permeable membrane. So what is semi-permeable membrane? Semi-permeable membrane is from the name we say this semi. It means that this membrane is only can be passed with the small molecule. Larger molecule cannot pass the semi-permeable membrane, right? So only small particle can pass to the semi-permeable membrane. So actually, this is a movement of solvent. This is important. A movement of solvent. The solvent that will move from low to high concentration, right? So if we want to see again from the video, we will understand more clearly. Let's see again the video. I will
down their concentration gradient across a semi-permeable membrane. This membrane is semi-permeable.
Okay,
Molecules can pass through, but solute molecules. The beaker on the screen
here
shows a
we have two solutions. Solution with low concentration and solution with high concentration. The blue is the water molecule and the purple is the solid molecule. So the left one, it has less solid molecule. So the left one is the less concentrated. The right one is more concentrated solution because they have more solid molecule. This is only 2 solid molecule. Here we have 4 solid molecule. So this is left one less concentrated, right one is more concentrated.
Permeable membrane separating a
They are separated by semi-permeable membrane.
Solution with a low solute concentration on the left from a solution with a higher solute concentration on the right. There is an overall passive movement of water molecules from the solution with a low solute concentration.
As you can see, there is a passive movement of the water molecule, which is the solvent, water molecule from low concentrated to the more concentrated solution. So the one that passed to the semi-permeable membrane is the water molecule or the solvent molecule.
To the solution with a high solute concentration.
As you can see, when the water molecule passes to the semi-permeable membrane, the less concentrated molecule will decrease the number of water, and the more concentrated will have more water. So here, the number of water will make the volume of the more concentrated solution will rise. Yeah, the volume is rise here. So this process is called as osmosis process. When the water molecule flowing through from semi-permeable membrane from low to high concentration. All right, this is osmosis process. How about osmotic pressure? Now, osmotic pressure we can define like this. Osmotic pressure is the pressure that must be applied, the pressure that must be applied to the solution to stop, this is important, to stop the fluid movement when a semi-permeable membrane separates a solution from pure water. Actually, it's not only pure water, yeah. The semi-permeable that separate two different concentration solution. One of them is low, one of them is high. So when the concentration are different, we know that there will be osmosis process where the water molecule will pass through the semi-permeable membrane from low to the high, isn't it? And the low concentration will decrease, and the more concentration will increase the number of water, it will raise. So to stop the movement of the water molecule or solvent molecule from low to the high, to stop this one, you need to exert a pressure, yeah, and this pressure is from the hydrostatic pressure. You have to exert a pressure to stop this movement of particle, a solvent particle, and the pressure that applied to stop the movement of the particle, solvent particle, is called as the osmotic pressure. Okay, in roughly we can say that the pressure that we apply to stop the osmosis process. Okay, we can say like that. So if we want to see again from the video, we can understand clearly maybe.
This is because the water molecules move to even out any difference in concentration, just like in ordinary diffusion. This net movement of water molecules will cause the water level to rise on the right and fall on the left. Hydrostatic pressure is the pressure exerted by a fluid due to the force of gravity acting upon it. As the column of water on the right gets higher, the hydrostatic pressure it exerts increases. The hydrostatic pressure acts to push the water molecules back across the membrane, opposing the movement of water by osmosis. At some point, this pressure is high enough to stop the net movement of water through the membrane by osmosis. This pressure is known as the osmotic pressure.
So osmotic pressure is the number of pressure exerted or applied in this process, in the osmosis process, to stop that osmosis process, to stop water molecule pass through the semi-permeable membrane. That pressure we call as a osmotic pressure. Is it clear the difference between osmosis and osmotic pressure? Is it clear?
Yes.
Right. Now let's come to one more thing. I want you to research a little bit in Google or any other sources. I want you to see the definition of reverse osmosis. What is the definition of this? Reverse osmosis. Please, can you make a research about this? Anyone get the answer? What is reverse osmosis? Anyone?
May I?
Yes, please whisper.
So reverse osmosis is a water purification process that uses a partially permeable membrane to separate ions, unwanted molecules, and larger particles from the solution.
So it is used as purification method, isn't it?
Yes.
It is used as a purification method in water, yeah, to purify the water. It's very important in our life. So again, there will be a semi-permeable membrane. Let's say that this is semi-permeable membrane. Now, let's say that in the left side, I have only water. In the right side, I have solution. Mana yang aman diminum? Which one is safe to drink? Huh? Water or solution?
Water.
Of course water ya. Solution, we don't know what is inside the solution. Kalau solutionnya sirup aman, tapi kalau solutionnya solution yang lain yang bisa membunuh bisa bahaya. Solution misalnya KCl, waduh, kalau diminum bisa langsung berinteraksi dengan tubuh. So water is safer to drink, of course, if the solution. So if you remember osmosis process, the movement of the particle from left to right to right to left, from water to solution or solution to water. Osmosis.
Water to solution.
Water to solution.
Osmosis in this way, right? This is osmosis process. So if there is an osmosis process, airnya akan habis lama-lama nih. The water will be decreasing ya. But we need water to drink. So that's why I need water. I need to get water from the solution. Saya harus ngambil air dari solution juga. Dan I have to purify this solution so I can get only the water, not the particle inside. How to get that one? So to stop this one, we need osmotic pressure, right? To stop this movement of water, we need osmotic pressure, isn't it? Tapi osmotic pressure is only stop the movement of water, isn't it? Dia cuma mencegah water molecule will go from water to the solution. Nah, gimana kalau kita mau mendapatkan air lebih banyak? How I will get more water? Not only stop water flowing from to the solution, but I have to get water from the solution. So I have to do what? I have to do more pressure here. And the pressure must be bigger than osmotic pressure. I have to give a pressure that is bigger than osmotic pressure. Apa yang terjadi kalau pressure-nya lebih besar daripada osmotic? What will happen?
The water from solution will move to
Yes.
the pure water.
All right. The water will flow from solution to the pure water to the fresh water. This process we call as a reverse osmosis. So reverse osmosis is the pressure that is applied to make the solution release the water. The solution release the water. And this pressure must be bigger than osmotic pressure. If it is smaller than osmotic pressure, reverse osmosis will not happen. So by this reverse osmosis, we will get more fresh water. Jadi yang dari air dari laut itu kan, from the sea water, it is a solution, right? It's containing salt. So I can purify that salt to become a fresh water that only contain water by doing what? By doing this reverse osmosis process. I exert some amount of pressure which is bigger than osmotic pressure of the solution, and then I will get that fresh water. All right, is it clear up to here? Do you have any question? Can I clear this? All right. Now, the next part is how I can calculate the osmotic pressure. And osmotic pressure is the example of colligative properties. This osmotic pressure not depends on the type of the substance. Ya, ini nggak bergantung pada jenis zatnya. Osmotic pressure only depends on the amount of the substance. So what unit of amount that used to calculate the osmotic pressure, the unit amount that used to calculate this osmotic pressure is molarity. According to the experiment that done by one scientist, Van Hoff, he is using the ideal gas equation. Yeah, we know that ideal gas equation is P times V is equal to nRT. This is coming from ideal gas solution equation, ideal gas equation or solution. If it's from ideal gas, if it's we're talking about gas, generally this P is become normal P, yeah, pressure. But when talking about the osmotic pressure, P become pi. Now let's say this is pi in mathematics, pi. Yeah, and we have this correlation of equation. I can rearrange this equation. Pi is equal to N over V times R times T. Yeah, and this N over V is, we know it is molarity. So pi, or the osmotic pressure, will be equal to mRT, where pi is the osmotic pressure, m is the molarity. We see that they are directly proportional. And R is the constant. We call that R as a gas constant. This R is a gas constant, and the value of R is always the same. It is 0.082 when we are using the pressure in atmosphere. Okay. The R value is 0.082. It is always be the same. Actually, if we want to make the unit of this R is L atmosphere per mole Kelvin. This is the unit of R, and it's gas constant. And T is the temperature, and this temperature must be in Kelvin. I think everybody know how to change the Kelvin into Celsius into Kelvin. So Kelvin is equal to degree Celsius plus
273.
yes, 273. All right. So this is the formula to find the osmotic pressure. Right, let's do one example of this. Calculate the osmotic pressure of sucrose solution (0.001 molar at 25 degrees Celsius. It's quite easy question. Right, how to calculate it? Just put P is equal to mRT, molarity times R times T, and M is already given 0.001, R is 0.082, and T is 25, it's plus 273 is 298. So when you calculate this one, you will get the answer 0.024, and the unit will be atmosphere. All right. This is how to use the formula. Is it clear? All right, can I clear this one? Can I?
Yes, sir.
All right. Now, one last thing that I want to explain here. We're going to see that how the osmotic pressure is important in our body. For example, if I have a red blood cell, yeah, red blood cell. Okay, in red blood cell, inside the red blood cell, we have also solution and we have the environment. Okay, if the environment and the solution inside the red blood cell have the same osmotic pressure, yeah, if the osmotic pressure is equal with the environment, equals to the environment, so there will be no transfer of liquid, yeah, from the blood cell to the environment. So they are seimbang, they are in equilibrium. We call this condition as isotonic. Yeah, we call this condition as isotonic. There is no osmosis pressure, what we can say, osmosis process. If the amount of, let's say, the amount of molarity of the red blood cell with the environment is equal, osmotic pressure will be equal, so there will be no movement of water. So there will be isotonic. But if the in the red blood cell, yeah, if the molarity is a concentration, let's say concentration is smaller than the environment, what will happen? Kalau red blood cell concentration-nya smaller than environment, let me draw this one bulat ya, biar mempermudah memahami nanti. Kalau dia isotonic, red blood cell nggak terjadi apa-apa, like this. But if concentration is lower in red blood cell, what will happen? Osmosis will happen. The water from the red blood cell, because it has lower concentration, will go out from the cell. And what will happen? The cell will shrink. Mengkerut ya. What we say this one, a crenation will happen. Atau the red blood cell will mengkerut because the water is go out. This condition we call as the hypertonic, where the condition, the red blood cell have lower concentration than the environment. Hypertonic, crenation is happening, or the cell will become shrink, mengecil, mengkerut. But in other condition, when the red blood cell concentration is bigger than environment, okay, at this time, red blood cell will expand and it can be explode. Yeah, this condition is called as the hypotonic, where the cell is expand or it can be explode also. Yeah, because of water coming to the inside to the cell. Jadi kebalikan ini, kalau lebih kecil airnya keluar, kalau lebih besar konsentrasinya airnya masuk. The water is go into the red blood cell will become expand or somehow it will be exploded and it also will be dangerous. This condition we call as a hypotonic condition. Sorry, hypotonic. Hypo. So we have three. Isotonic, this is the safe one where the osmotic pressure is equal, there is no osmosis process. In equilibrium, everything is okay. But if we have hypertonic or hypotonic, it will be very dangerous. Either it will be shrink the cell or the cell will be explode. Both of them are dangerous. So what we got from here, we understood that something that is not in equilibrium is always dangerous. Let me write again here, hypotonic. Here is hypertonic. Okay, is it clear? All right. Do you have any question? We finished the what we call colligative properties. Actually, there's one more thing, colligative properties for the non-electrolyte. Yeah, for electrolyte solution it will be different, but I'm going to skip first that one, and we're going to proceed on another topic. Colligative properties for the electrolyte. But I'm going to skip that one first. Oke, jadi dari sini ya, dari red blood cell yang ada dalam tubuh kita bisa memahami bahwa keseimbangan itu penting. Kalau seimbang, kalau sama, mengikuti sesuatu yang tidak berlebihan atau kekurangan, maka aman. Tapi kalau kekurangan seperti ini, konsentrasinya kurang, bahaya. Apalagi konsentrasi lebih juga berbahaya. Kurang dan lebih itu berbahaya. Kalau dalam agama disebut ifrat and tafrit. In Islam, we say ifrat and tafrit. Kekurangan dan berlebihan, both of them are not good, but something which is equilibrium, which is seimbang, is the best one, like our example in here. All right, that's enough for the first hour. In the second hour, again, we are going to solve some question. I'll give you some question, and you are going to solve it in 45 minutes, and no matter how many questions you solve, just you will upload it to the Google Classroom ya. Jadi bukan PR ya, langsung di jam itu juga. Berapapun yang kamu kerjakan, 1, 2. But I will give you 6 questions. Not much. Maybe you will do all of them easily. In 15 minutes, kalau selesai bisa lanjutkan soal-soal yang lain. Oke? See you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, sir.
Thank you, sir.